Graphing systems of linear inequalities follows the same steps as graphing single linear inequalities. The big difference is that you will have two areas of shade instead of one. And from the two shaded areas, you're going to need to keep the overlapping shaded area. That means you want an area that makes both inequalities true. So we're going to graph the first system, 2x plus y is less than 3, and y is greater than or equal to x plus 3. So let's turn these into equalities first. So 2x plus y is equal to 3, and then y is equal to x plus 3. I like to do y equals mx plus b, but you can use whichever method you want to graph yourself. So solve for y, subtract 2x over, and I'm going to get a slope of -2 and a y-intercept of 3. And then I'm going to get a slope of 1 here and a y-intercept of 3. So let's do the first one here. My y-intercept is 3, so 1, 2, 3. And then my slope is -2, so I'm going to go down 2 and over 1. And since my first line is a less than with no equal to, my graph is going to be a dotted line. Next, I'm going to graph this one. My y-intercept again is 3, which is right here. And my slope is 1, so from here I'm going to go up 1 and over 1. And since this is greater than or equal to, I'm going to draw a solid line here. So I now have my two lines drawn, and now I'm going to find a test point. As long as it's not on one of the two lines drawn, I can use whatever I want. And I'm going to choose something nice and easy. I'm going to choose 0, 0. So test point 0, 0. So now I'm going to plug it back into both inequalities to see if they're true. Test point. So 2 times 0 plus 0 is less than 3. 0 is less than 3. And this is true. And then just get it all done at one time. 0 is greater than or equal to 0 plus 3. So 0 is greater than or equal to 3. And that is false. So let's do the first one. The first one was the dotted line, which is right here. And I said that this test point was true. So everything on this side of the dotted line is true. So everything over here is true for the dotted line. Next, I'm going to do what we got for the solid line, which was false. So everything below the solid line is false because our test point was false. So I want to shade everything above the solid line here, and that's what's true there. Now I have to look at this and see where is the area overlapping. And I can see that the area is overlapping here in this blue area. So it's easier to see when I get rid of the green and the yellow that that is the true area for both inequalities. Let's do another one. -2x minus y is less than 5. X plus 2y is greater than or equal to 2. So turn them into equalities. -2x minus y is equal to 5. And then x plus 2y is equal to 2. So solve for y, add the 2x over. So -y equals 2x plus 5. And then multiply everything by -1 or divide by -1, whichever you prefer. And I get that. So my slope here is -2. And my y-intercept here is -5. Solve for y here. subtract x over, so 2y equals negative x plus 2, divide by 2, so y equals negative 1/2 x plus 1. So my slope here is negative 1/2, and my y-intercept is 1. So let's graph the first one. Y-intercept of negative 5, slope of negative 2. So I'm going to go down to negative 5 on the y. And then my slope of negative 2 is down 2 and over 1. And this does not have an equal to sign, so I'm going to draw a dotted line. And then this one, my y-intercept is 1. And my slope is negative 1/2, so I'm going to go down 1 and over 2. And this is an equal to, so that means I'm going to have to draw a solid line between these 2 points. So a solid line, as best I can draw anyway, like that. So now, again, I'm going to pick a test point that's not on one of these two. And again, if I can, I will. I'm going to use 0, 0. So test point of 0, 0. So plug it back in to each inequality. So negative 2 times 0 minus 0 is less than 5. 0 is less than 5. And this is true. And then I do it for this one as well. 0 plus 2 times 0 is greater than or equal to 2. So 0 is greater than or equal to 2. And this is false. So now I'm going to shade what's true. So let's do the first one, the dotted line. The test point is off to the side, and it's true. So that means everything to this side of the dotted line is true. And now I'm going to do the next one, the solid line, and it was false. So everything below the solid line is not true, so I want to shade everything above the solid line. So everything up here is true. And bled over a little bit, that's okay. And now, again, we want to shade the side that is true for all in this system. And we see the green and yellow overlap here, so it kind of goes along the dotted line, and then it goes along the solid line. And that's a lot going on, but let's just clear out the yellow and the green. And this is the area that's true for both inequalities. Last, a nice easy one. X is greater than negative 4, y is less than or equal to 3. So x is equal to negative 4, y is equal to 3. So x equaling negative 4 is a vertical line going through the x-axis at negative 4. So we're going to go to negative 4 here and draw a vertical line that is not equal. Has no line there. So that means ours is dotted. And then y equals 3, going through the y-axis at 3. It does have an equal to, so this is a solid line. We're going to choose our test point. No point in deviating from the easiest way, so we're going to use 0, 0. And we're going to plug it in and see if it's true. So we only have an x here and no y, so we just plug in what we can, which is just 0. So 0 is greater than negative 4. And that is true. And then 0 for y here. So 0 is less than or equal to 3. So is 0 less than or equal to 3? Yep, true as well. So x is the vertical line, and everything on this side of the vertical line where the test point is true. So we're going to shade everything over here. Next one, y is true here. So everything below the solid line is true. So we're going to shade everything below. Now, where do the shaded areas overlap? They overlap here in this little corner. So let's get rid of yellow and green. And we can see that this is the shaded area that is true for this system of linear inequalities.